Hi, everyone. I hope you can hear me. I'm Michael. I'm the founder of the Data Incubator, and we're going to be doing this short web broadcast on data science and how to do data science in 30 minutes. So first, maybe I'll say a few words about myself. I'm actually a mathematics or applied math PhD. I did my work at Princeton and Cambridge. I've worked at places like Google and Foursquare and Andreessen Horowitz. And in fact, actually at Foursquare, I ultimately ended up heading up data science for the monetization effort there. Since then, I've started the Data Incubator, where we train masters and PhD students with a strong background in math and statistics and help them make that transition from academia into industry. So I'm going to now try to share my screen. So hopefully you will be able to see that shortly. Cool. So maybe I'll just start at the Readme. I hope all of you have a link to the GitHub repo. So the repo is at our website, and I think it's also contained in the Eventbrite that you signed up at. When you open up the event, when you go and check out the Git repo, you'll see the README, and this is a less pretty version of that README, but it just sort of walks you through the steps of getting started. So again, this is a sort of 30-minute introduction to dip your toe into data science, and the idea is to see what you can do in 30 minutes with a little bit of programming and a little bit of science. And of course, this is an open source contribution, so if anyone sees anything that they think should be added to or modified, I would really welcome you to do that and submit a pull request. So the first thing you'll need to do is install the requirements. So pip install requirements.txt. Pip is Python's package manager. We're also going to be using the Twitter API, so you'll have to go and request your Twitter credentials. I think we sent out in an email beforehand telling everyone that this would be a good thing to do. But if you haven't, you can do so now and put the secrets into your Twitter secrets.json.no-git file. And then you would run this command, ipython notebook, which basically starts this entire ipython notebook. It'll pull up a server, most likely on port 8888, but perhaps on a different port. So as you can see, I'm on port 8891 because I do a lot of development. But it'll start that port up. It'll give you a screen like this. And then you should probably click on ds30.ipython notebook, and you will come here. So let me not spoil the surprise. I'm going to clear the outputs, and I'll start talking about doing data science in 30 minutes. So let's see if I can keep on time. So maybe the first thing I'll say is what we're doing or why we choose Python. And well, I think there's a number of reasons. The first one might be that IPython notebooks, which is this sort of notebook interface that you see right now, and hopefully that you have up running on your local computers, this is a really good pedagogical tool. So these little cells, they will actually execute code. And it allows us to sort of run some code and talk about it. And it also means you have a copy of the same code that you can run on your local machine and play with it as I'm going through this, this webinar. The second reason we like Python is that it strikes a really good balance between being flexible, it's an interpreted language, but also having the speed that you need. So the core machine learning and kind of linear algebra routines are all written in Python, which is this strange hybrid between C and Python. And so when it needs to be fast, it's fast. but when it needs to be flexible, when you're just sort of prototyping and playing around with things, it's an interpreted language, so it allows you to have that freedom. So Python also strikes a good balance between being a programming language, that is having a really extensive population that supports it and supports the libraries that it has, as well as having specialized machine learning routines. So all those features that you're really used to, like R data frames or the machine learning routines in MATLAB, all those have been made available through libraries like NumPy, SciPy, Pandas, and scikit-learn. Now, with all the good things, though, there are some downsides. And one of the big downsides is actually that Python is kind of a tough language when it comes to installation. And in sort of managing those dependencies and managing those libraries can be kind of a pain. So, and it's a really unfortunate thing because these sort of installation projects, these kind of DevOpsy things, they're things that you only really need to do once. But there's a really steep learning curve, and it's the first thing you have to do. So unfortunately, I think that keeps a lot of people from starting on data science things or learning about data science because of that initial steep learning curve just to even get started. And I think some people have experienced that as they try to install the packages for data science in 30 minutes. As a side note, for the fellows and scholars in the data incubator, we actually just provision an environment which has all the tools pre-installed. We've sort of figured out how to install them, how to keep all these packages nicely synchronized, if you will. So it's a thing that we can solve for our fellows, but it's hard to do when you're trying to host a webinar for 500 people, or actually 2,000 people, which is the number of people who signed up. So without further ado, let me start. And the first thing I said is that Python has, or one of the first things I said was that Python has this really strong core of programming language support that comes with lots of libraries that have been built by the community and that are all open source. And you can see that that's completely true here. So these are just some of the libraries that, well, these are actually all the libraries that we need to import. But it gives you a sense of how we're able to do something so quickly, build a little data science project in 30 minutes. And it's because we're really leveraging the code that other people have written. And as Newton said, standing on the shoulders of giants. All right, so the first thing we need to do is, so our project is going to be to sort of pull down, get some live data from Twitter, which will be exciting because I actually don't know what Twitter is, what people are talking about on Twitter at the moment, but I guess we'll find out. We're going to programmatically try to access Twitter, pull down this data in real time, and do a little bit of analysis on it. So the first thing we need to do is access that data. In order to do so, we need to authenticate. And as you can imagine, we need to authenticate because Twitter doesn't really want to provide resources to people willy-nilly. But they do want to have an open API. And the way you sort of strike that balance is you make people identify themselves through OAuth tokens, and then you rate limit how much any given person can use the service. So you'll have to sort of create a Twitter account, get your API credentials by following this link. And when you do, you should be able to put them into a document or into a file, which is a NoGet file. We have not checked in, so I have a Twitter secrets.json.noget file. The format of that file, by the way, is on the README in case you want to know how to sort of assemble the file. But as per good programming practice, I have not checked that file into source control because otherwise you would see my secrets, and that would not be good because then you could be able to go masquerading as me. But anyone can go and sign up for these Twitter credentials, create their own secrets, and put them in that file. And the first thing we're going to do is actually load that. And once we've loaded this using simple JSON to parse the format, we can then put this into an OAuth object and use that to request Twitter data through a stream. So now Some of you might not be familiar with a stream, right? We're going to request a stream. So let me just say a few words about that. The idea of a stream, you can think of it as an infinite list. It's in principle like a list, but some of those things haven't been created. So when we're running the stream, it's going to give us a stream of the live updates from Twitter. So you can think of it as the list of all future updates, some of which haven't even been tweeted about right now as we're running the code. But as they come in, they'll be sort of fed in to the stream. And we're going to be a little US-centric here. We're going to use a bounding box. So these are the latitude and longitude bounding boxes for the US, or roughly. That's what this argument is. We're going to say that we want to stream. This is the API endpoint that we need to hit to get the latest tweets, which are called statuses in the Twitter API. And we'll, of course, have to pass in our authentication. Now, I said this is a stream, and I said it was kind of like a list. And the sense in which it's kind of like a list is that you can run a for loop over it. So if you've written in Python before, if you've written in any language, this is a lot like the kind of for loops that you might be familiar with. Now, in order to process this thing looks like a function. But for those of you who haven't seen it before, it's actually what's called a generator. And that's because instead of having a return keyword, we use this yield keyword. You can think of this as almost like a function that returns multiple times. But what's happening is that every line that's coming through, we're going to then output that or emit that to the context that's calling us. But before we do that, we're going to have to do a little bit of processing. And we're going to sort of ignore these keep alive messages, which are always being sent across the wire. And we're going to only yield the part of the tweet that is the actual tweet message. So this is just going to give us back the tweet messages and not any of the metadata that Twitter is giving us. So I'm going to run this. Now, of course, this is just a definition of a generator. So it's only defining the generator. And a few maybe pro tips. You might have noticed that I like to use simple JSON and not JSON. For whatever reason, the default JSON library is actually really slow in Python. So you should definitely use simple JSON, which is like much faster. And then the default URL handling library is called URLlib. It's actually not very good. It's kind of a bad interface. You really probably want to use requests, which is what most people who do this stuff for a living use. So now that I've defined that function, let me actually just print out some tweets. So this is going live to Twitter and pulling back tweets from the Twitter API. You can see people are saying, got my third nipple cut off today. Wonderful. 16 more days. I'm not sure what they're counting down to. But you can see that this is a live set of tweets that are happening roughly within the US. And you'll notice that in order to do this, I'm basically going to loop over the generator. So I can treat the results of a generator almost as if it's a list. But of course, it's sort of running forward. Or it's kind of pulling these things down in real time and spitting them out on my console. And yes, I am doing this in real time along with you. So I actually have no idea what the tweets are saying. This is not faked. One thing you might want to notice is that there's this notion of an islice. So I'm sure you know that in Python, you can slice a list. Well, if you have a generator, you can't quite slice it. So you have to use a package called itertools, which allows you to handle streams and generators and things like that. And then instead of using a slice function, you'll be using an islice function. And all this is saying is return me the first 100 of these. Because this tweet generator will go on forever. It will keep on returning you things. But by using islice, we're saying I just want the first 100. And that's why this has stopped after it's printed out the first 100 tweets. All right. So actual tweets are kind of not interesting. Instead, let's try to collect some statistics about that. So a really simple thing we could do is to look at word counts. And let me skip down here to the code. So what we're going to do is we're going to keep track of, we're going to use the counter object in Python. And the counter object is just a really convenient way of counting things. And in fact, you'll see here that at some point I pull out the words, and I'm just going to say counter of word plus equals 1. So this is an example of where knowing how to use a library can save you a lot of time, because this is a common idiom that you'll use a lot in data science, and being able to leverage that counter object to do this very simple and very common thing is really powerful. So something you'll notice if you do a lot of natural language processing is that if you look for the most common words, which is what we're going to do here, the most common words are almost always boring. They're things like the or a, or other words that are not very interesting. And that's when the notion of stop words comes in. So stop words are words in English that are so common that whenever we process data or process textual data, we actually just throw them out. So it turns out that NLTK, which is a package that you can download, and what we have downloaded, contains a list of stop words for the English language. In fact, I think they contain a list of stop words for many languages, so you can do natural language processing in a very multilingually. But we're going to grab a list of stop words, get this list of stop words that they have recommended, and we're going to filter things out by this. So you'll see that here I'm using the tweet generator to pull out a bunch of tweets. So this is where the tweets go. For all the tweets, I'm going to first of all just normalize with making sure they're all lowercase. And I'm going to split each word or each tweet along the words. That's what .split does. So this is now pulling out each word in the tweet. And then as long as the word is not a stop word, so it's not in this library, this set called stop, I'm going to increment a counter. So now I'm just counting up these words. And then I have this constant called display every. And what I'm going to do is every 20 tweets that comes through, I'm going to output the results. So you'll see here that I'm going to just write out the current count of the most popular words. And to keep track of the most popular words, or to keep track of the counts of all the words, I have a counter and a counter object. But I also need this function, n_largest. And you'll see that n_largest basically uses a heap queue to keep track of, or to pull out the 10 largest objects in this based on some key. So in this case, right, a counter.items is going to be pairs or tuples of words and the counts associated with those words. So I'm just going to pick the 10 largest words associated by the count part of this tuple. And once I get that, well, I'm going to just I'm just going to cast it to a string and print it out to the screen. Now you'll notice that I'm not using the word print or the keyword print. Instead, I'm using system.standardout.write. And the reason is because print will actually automatically append a new line. And so every time I print one of these, it will, sort of like what I did here, it will just keep on flowing this down. But because this is real-time information, and I only really care about the count right now, not the count 20 tweets ago, what I really want to do is not put a new line, but use a carriage return. And you'll see that what a carriage return does is it actually erases the last line and writes over it, which is exactly the behavior I want. So I'm going to print this, run this just so you can see. And you'll see that the most popular words, the 10 largest words, or sorry, the 10 most popular or most used words are being shown. So apparently a lot of people are talking about jobs and hiring right now, which is kind of interesting. Apparently that's a trending topic. Career arc is a trending topic right now. So it's really interesting to be able to see this coming out live. This is exactly what's happening right now on Twitter. Now, you'll also notice that I have this finally clause. And what we're doing is, the reason we have this finally clause here is so that if I ever, I can sort of trigger a keyboard interrupt and stop the process prematurely. Or I can just let this, this line of code run until it finishes. And it will finish when it pulls down the first 1,000 tweets. But either way, it's going to then run this clause finally. And what it's going to do is, again, get the 10 largest words 10 most popular words, and then it's going to plot them. I happen to like, it's kind of unnecessary for me to use a pandas data frame, but for the sake of illustrating this, I figured I would. And it also illustrates the fact that pandas data frame does this nice labeling of all your axes for you. This would actually be a lot more code if I had to do this manually in matplotlib. But because I know this sort of trick where you just put everything into a data frame and then you plot it, it actually does pretty good plots with very good labeling. So this label and the labels along the x-axis and this label here, they come for free. Two more quick points about this. One is that you'll notice that I've used this enumerate keyword. Enumerate basically says, return me this list. Well, return me all the elements in this list or this generator or this stream, but add a number, which is basically the index of that. So it's, k is going to be 0 for the first tweet, 1 for the second tweet, and so on. And I can use that now to keep track of every 20th keep track of every 20th element and only write this text out every one in every 20 times. So that's really useful. The other thing is you'll notice this plot is actually kind of nice, and most plots in Python are not. That's because we've included this magical keyword seaborn. Import seaborn as SNS. So this is a little thing where if you import it, they overwrite the default parameters or the default plotting settings of matplotlib to make them prettier. It is a little slower to run, but I find that it makes the graphs much more aesthetically pleasing. So I always do that by default. So cool. All right, and let's see if I've forgotten to say anything. Yes. So one last thing is the way you actually keep track of the n largest words is using something called a heap queue. So it's a way of keeping track of this, keeping track of sort of the n largest elements, or in this case, the smallest element. So that's very easy to remove the smallest element. And that's actually, as it turns out, really useful if you want to build a list of the n's biggest things. If you want to learn more, you can go, you should Google heaps and queues and learn about how to make your code run a little faster with something like a heap queue. It's also useful because this function heap queue.nlargest is a free function you get from Python, and we all know sort of it's free, like it's a library that you can just use, and B, it's really it's actually optimized, so it actually runs very quickly. And it's just an example of another idiom that you often have in data science and how you can leverage libraries in Python to really reduce the amount of code you have to write and increase the speed at which you can deliver that, deliver results. So the next thing is, well, maybe we want to visualize this, right? So like this running list is kind of hard to read. And it's nice that I have this chart here at the end, but maybe I can do something a little bit fancier. So instead of using a list of words, let's use a word cloud. And I'm sure you all know that a word cloud is a sort of an illustration where the size of the word corresponds to the word in this sort of mosaic of words, corresponds to how frequently that word occurs. And it turns out there's a library for that. So let me run this. So again, this is pulling down the data live, and it's just updating this word cloud with the most popular words that are being used right now on Twitter. So apparently people are saying today's a lot. They're saying ever a lot. And you can even see a few Twitter handles of the people who are trending right now. So, and it's kind of cool, right? Because just between, I don't know, 10 minutes ago, 5 minutes ago, here, and now you can see that the results are totally different. People were talking about jobs. Now the conversation's completely moved on in social media. And again, remember, this is all happening live. Okay, so this is great that I can tell you what topics are trending or what words are trending. But let's pull it down and try to break it, do something a bit more intelligent than that. And so the thing we want to do is actually it's called topic modeling. So there's a notion of online versus, okay, so I guess maybe I should explain a little bit about how this works. So first of all, we need to batch our tweets. So if you'll take a look here, what I'm going to do is take the iterable of all tweets and batch them up by size. And the idea of what this does is if you run batch on a list like this, it will return you back a list of lists. The first element will be the first 3. The next element will be the next 3, and then sort of remaining elements as we go along. Again, this is all using Python generators and this yield keyword. It really saves you a lot of time in writing your code and makes it very modular. And the reason we're doing this is because we're going to be running a Kmeans clustering on this. And we want to basically take a series of, well, the batch size here is 20. So a series of 20 tweets and feed it into the machine as these batches of 20 tweets come along. So we're gonna have 4 topics. So that's what the cluster size is. Probably should be renamed N clusters, really. And then let me say a little bit about this. So we're going to be doing Kmeans, but the regular Kmeans algorithm you probably are used to uses streaming rather than, or use those sort of things in batch rather than streaming. So it's doing offline as opposed to online. So offline means you have all the data, and you're going to take all that data, put it into your RAM, and train it. Our use case is different, right? Because we're getting data live. It's coming through. These charts are coming through every single time. And so in order to, these tweets are coming in real time, and we need to be able to process them in real time. So we need to use a streaming algorithm. It turns out that there exists a K-means clustering algorithm that is online, that does work with live data, and that's what we're going to be using. So now we're going to do something a little cheap here. We're going to, well, first let me say this. We're going to, once we have these words, in order to do any sort of machine learning on them, we're going to really have to vectorize them. So how do you vectorize? Well, it basically means taking a sentence like this and turning it into a vector. And the way you do that is basically word counts. So here, for example, the first word is be happy. And what we're going to do is we're just going to mark a 1 in the column that corresponds to that word. So be here is going to be 1, and happy is going to be 1. And apparently they wanted to mark the expression be happy as 1 as well, because that's the word that they wanted to count. On the other hand, if there's another tweet which is quoting Hamlet, you will mark a different set of 1s. In fact, you'll mark a set of 1s that correspond to be or not to be. And this is actually doing not only the words in this picture, we're doing not only just the words, but all the bigrams. So all the consecutive 2 words combinations, like be happy or to be or be not, or not to, and so on. So that's where all these 1s are coming from. Now, the way we're going to do this is we're going to have a fixed vocabulary. So there's a list of words defined right here, which I'm just going to read off. It's a dictionary of something like the top 10,000 most popular words in English. And I'm just going to confine my search to those. And basically, each column will correspond to a number, and it will probably be based on the order in which these words are read in. Now, of course, you can do smarter things. You can have actually dynamic vocabularies. You can use the hashing vectorizer to sort of stochastically build a vectorization scheme, which is almost unique, but not quite, because you're using hashing. But I'll leave that for another day. For now, just to keep things simple, and this is often a good thing to do when you're just prototyping something, which is what we're doing now, I'm just going to run with a fixed vocabulary. We'll also use sparse matrices, because as you can imagine, there's tens of thousands of words in this vocabulary, multiplied by potentially millions of tweets. but most tweets are not going to use most words. Or actually, all tweets will use only a small subset of the words available in the vocabulary. So most of the cells in this matrix that we're forming are going to be 0. In order to do that, in order to store that in a memory efficient way, we'll be using sparse matrices. And finally, after all that intro, let me just say a few words about K-means clustering. So this is the so K-means is sort of a way of doing unsupervised learning. So what's unsupervised learning? Well, usually when you think of machine learning, you think of learning some sort of relationship between your features and your outputs. But that presupposes that you have outputs, that you know what your dependent variables are. If you don't have any structure, if you don't know what those are, then you need to run unsupervised learning. And that's what K-means clustering does. So if you only have features, you would, for example, here we would have features because we have these tweets. The tweets can be turned into vectors. And then if you imagine sort of just a 2-dimensional vector space here, each tweet would then correspond to a point on this vector space. And what we need to do is then separate the points based on the ones that seem to close together, close to each other. And of course, there's a little bit of a black magic here of trying to determine, well, how many clusters do we need, etc. But oftentimes when you run K-means clustering on unlabeled data sets, you can actually get out very interesting results. So here, for example, we've run K-means clustering in these 3 data sets, and we can identify, well, these guys are blue, these guys are green, and these guys are red. And we're able to even compute the centers of these 3 clusters, so that's what these crosses are for. Now, the other thing I wanted to mention is that this K-means algorithm we're using is iterative. So it doesn't just say, give me all your data and then let me learn on it. It's going to adapt to that data as it's coming in. So here's the code to do that. This will plot all the word, and oh, by the way, what we're going to do is we're going to compute what the clusters are, and then we're going to do the word clouds for each of those clusters. So we're going to look at how these different topics are going to, or what the vocabulary, the most popular vocabulary words associated with each of those topics is. So I'm not going to go too much into this code. A few things to note are here we're constructing the sparse matrix. Well, first we ask for a blank sparse matrix. Then we create the sparse matrix by setting each word to so row corresponds to the tweet, and this word to index corresponds to the index associated with that word. We're going to set each of these to 1. So this is not going to build me that sparse matrix which you see here, the matrix of 0s and 1s, which corresponds to the tweets that we're getting. And then we're going to have this K-means object, which is constantly being updated. That's what partial fit means. It means it's constantly being updated by batches of tweets. And that's where this batch is useful. And then each time I'm going to, again, pull out the 50 most popular words this time associated with each cluster. And I'm going to plot those. So let's take a look. Now we're streaming these tweets live, so I actually don't really know what it's going to say. And these are the 4 topics. And so this is what's happening. So people are saying, I don't know, just get to work or something in this column. It's hard to tell. Saying great things, and eyebrows and face. That's apparently this other topic. So you can see that we're able to find at least 4 different sets of vocabularies that people are using. And if you start looking at these, you might be able to find a sort of a coherent narrative about what they are really talking about. Now, obviously, I'm not going to run this for a very long time. It actually takes a lot of data to really train a good topic model. But you can start to see that even with just, I mean, we're probably up at 500 tweets, we're able to start picking out a little bit of structure where different sets of people who are saying different things are being clustered into different topics. All right, so I will let that run for a little bit. And then just to finish off, since we're talking about topic modeling, I figured I would introduce latent Dirichlet allocation, which is a pretty fancy, which is a pretty fancy form of topic modeling. And the way it works is it's a Bayesian thing. So here is the Bayesian graphical model. And if you're a Bayesian, you would sort of look at this and say, ah, amazing, I know exactly what's happening. But for those of us who are not as Bayesian, what's happening is we're basically assuming that each document, or that in the world that there are n topics, and every document is a distribution over those topics. So some might be more about politics and others might be more about sports. And each topic in turn is a distribution of over words. So articles articles are talking about politics might mention Republicans and primary and Democrats more often. Topics are talking about sports might mention football or baseball or the Green Bay Packers more often. And so by having this sort of hierarchical model where you say each document is composed of a series of topics, and each topic is composed of a series of a distribution over words, we're actually able to sort of derive, based on the words that are actually in the document, we're going to be able to infer what topics that document was talking about. Here's a sort of illustrative example where they looked at a nature paper, or a science paper, I'm sorry, and there are all these topics, like the blue topic is clearly about computers, the yellow topic is clearly about genes and genetics, and then you're able to, from these words, infer what the topics are, and then be able to make a statement like, this paper is 50% about genetics and 25% about computation. So it turns out that there are online routines to do LDA, or latent Dirichlet analysis. Wait, is it analysis or allocation? I forget. Latent Dirichlet allocation. And apparently I need to learn how to spell allocation, but I'll fix that for later. And you can run the same thing. So here we're going to iteratively update this model. And again, we are plotting the 4 word clouds associated with each of these 4 different topics. And you can tell that clearly someone is talking about sex. And that's a major topic right now. Apparently people are also talking about jobs again, or at least they were, as jobs and studies. And so you can start pulling out these different words that people are talking about, or these different themes that people are talking about, and look at the most popular words associated with that. And it's kind of cool to just be able to sit back and look at these themes come up. All right, so I've gone about 9 minutes over time, but I'm going to blame that on the fact that I spent a lot of time introducing how to get started with this notebook. And I'm going to claim that I did this in 30 minutes. But if you want to learn more, or if you found this interesting, you might consider applying for our fellowship program. Again, it's totally free for all the fellows who get in. And of course, if you're interested in hiring data scientists, I would suggest you also come here and click here and sign up to be a hiring partner. Or if you're interested in corporate training for your company, we can certainly come in and do a little bit of training for your data scientists. So that is it for what I'm going to say. I believe there's actually a forum where people have given us, people can submit questions. I'm going to quickly try to figure out how to find that forum. And when I do, I'm going to be able to answer your questions. So let's see if this works. All right, so I'm on our YouTube page on my phone, and I do not want to post a comment, but it doesn't seem to say that I can actually look at the questions that people are asking. So maybe this is a good time to. All right, I'm just going to go bug our ops guy and see if he knows what questions people are asking. And I'm happy to answer them. All right, but in the meantime, because I think this is kind of cool, I'm just going to go back and run one of these things again and watch the questions come in. All right, so I have the URL. Let's see if this works. All right. And, okay. So I see the chat here. And all right, I'm going to try to now read these questions in real time and answer them in real time. So a lot of people are saying great things about LDA, which I also think is pretty cool. Yeah, so you can definitely do a pull request. Git actually handles IPython notebooks quite well. Yes, and if you have any, it sounds like people are asking about how to contribute. So if you have any changes you would like to make, please do add them to the submit a pull request and add them to our GitHub. That would be really great. Some people wanted to ask, what are good resources to start with to learn about data science? So actually, we have a blog post about this. So I'm not going to not try to look for it right now, but I will see if I can submit an answer to this. Oh, I have to sign into chat. Well, I don't really want to sign in. All right, let me see if doing this kind of. So I submitted a link, and if not, I'll email this out later. But it's a link to our blog, and it actually contains a lot of resources on how to get started with machine learning, how to do numerical computation, how to get started with Python even. Okay, so a few people liked what I was doing, and yes, so somebody said that they were having trouble with the Twitter secrets part. So I think it's actually now on the Readme. So someone submitted a pull request to update the Readme to give a format for how the Twitter secrets needs to be formatted. And if you follow that formatting and you go to Twitter and get your credentials, you should be good. Any advice on getting the word cloud wheel to find my VC? No, sorry. I just pip installed it and it worked out of the box. Somebody asked about data incubator sessions. Oh no, I've lost you. So someone asked about data incubator sessions. So this is now our 6th session. Things are going pretty well. We have them in 3 cities, New York, DC, and SF. And we're actually going to be doing our first international location shortly. So keep your eyes out for that kind of announcement. Or if you're interested, you can follow us on Twitter to find out more. So somebody asked about what level of machine learning expected for a successful application. So I guess you're talking about for the data incubator. And yeah, so it's, we don't really expect people to know much about machine learning. That's obviously something that we would be teaching. And this is really for people who have a strong background in kind of math and science and who understand how to hack around on a computer and write some code. And that's really kind of the prerequisites. But if you want to learn more, you should definitely go to the web page and read the FAQs. And then the question is, do you accept applicants who are near the end of their PhD? Absolutely. Those are the kind of people we want to accept. Oh, so somebody said, how do you get larger time segments of data? So that's actually really straightforward. So you would come here, and what I've done is I've just set, remember, I've just limited this to the top 1,000 because that takes roughly the amount of time that it requires to finish this lecture or to sort of talk about each of these sections. But you can make this number larger, or you can even just remove it completely, right? And then this will run forever, well, or at least until your computer crashes. Just sort of doing this iterative K-means topic modeling. Can I run LDA on this chat? Yes, if somebody wants to go figure out how to interface this chat either by scraping it or by using the API, I think you could totally run LDA on this chat. And that would be a cool follow-up project. So somebody asked, hey, if I'm a master's student, can I apply? So yeah, so if you look, actually, the data incubator, we are looking for people who are master's and PhD students. So you can totally apply if you have a master's. What practical real-world problems can be solved with contemporary data science? Oh, that's a great question, Denzel. So I think there's a lot of questions. And if you take a look at sort of a cross-section of our employers, they're doing anything from finance, like getting getting low-income individuals credit, to ad tech, figuring out how to help people who write blogs monetize their blogs by sort of serving the right kind of traffic or serving the right kind of ads to both help the person who's going to the website find the product or service they want, and helping the person who's writing the content be able to pay for that content. All the way to like medical companies who are using this to help fight cancer, right? So there's a whole spectrum of problems that people use data science for, and actually quite well represented within the companies that we're partnered with. Somebody asked, is it necessary to have a strong background to apply for the data incubator? So obviously you don't need a background in data science, but you do need a strong background in math and stats and the ability to sort of do some hacking around in programming. So if you think you have that kind of background, I would definitely encourage you to, and you want to do more data science, obviously, I would highly encourage you to apply. All right, I'm getting the feeling that this is a almost never-ending list because every time I say something, more questions seem to pop up. So I'll spend a few more minutes answering questions, but at some point I might have to just stop. Yes, and in fact, there is a online session as well. So somebody asked about whether or not they had to be in had to sort of be in person, or if they could do things online, and there is absolutely an online session as well. Someone asked about how much programming do data scientists have to do. And I think that's actually pretty, as you can tell from this, right, there's a reasonable amount of software you have to just be able to, you have to be quite familiar with a reasonable amount of sort of software engineering, because a lot of, so what data science is about is really getting access to the tons and tons of data that's out there. Either out there sort of in the World Wide Web, where you can just sort of scrape it or pull it down from an API, or out there in the sense of being out in your company's database. And if you don't have the technical skills to be able to pull that data in, it doesn't really matter how much sort of analysis or stats that you know, because without data, analysis and stats is meaningless, right? So you really have to be able to know enough programming to be able to pull down and access this data. Do I recommend any textbooks or resources for us to read? Again, I'll make sure we send out a link. Let me write a note to myself. Link to further resources. And it's a blog post we actually wrote about this. So I'll definitely put that up. Yes, more people want me to. More people want me to deal with the sort of generate word clouds based on this chat. So hopefully, people will. Someone will decide to do that. Geotag tweets. Yeah, so actually the tweets that come in are already geotagged. So they already have, I think, well, they at least have lat longs, which may or may not be accurate. They may or may not have addresses, but you can always use OpenStreetMap and actually get real-time is it geocoding or reverse geocoding? But anyways, translating those lat longs into addresses. So that's already there. I am just throwing away that information because all I wanted was the textual tweet data, but you can totally do a project with that. Here's an interesting question. What's more important for becoming a good data scientist? More stats or more programming? I think it's a really hard question to answer, and it really depends on where you are. Obviously, if you're stronger on stats, you probably need to know more programming. And if you're really strong on programming, you probably need to know more stats. It's really sort of being able to understand the two things, because you need to. So if you have a lot of data, there are two things you need to do, right? One, you need to be able to mess with a lot of data, which means you are not going to be writing down numbers into tables and then adding them up by hand, right? You're going to need to get a computer to do that. And that probably will require programming. On the other hand, just because you can program doesn't mean you can make any sense of the data. So can you sort of just like, given some data, make a practical recommendation on, well, let's say you had I know a popular question that sometimes I'm asked on interviews is, here's a list of number of people based on number of times each first name is used in every year going back to like the 1800s. So you now have the popularity of those birth names. Tell me what name is the most popular now that wasn't popular a while ago. So you have to understand a whole bunch of statistical concepts in order to understand that, right? You have to know what it means to be significant. So maybe a name was only used 3 times 100 years ago and is now used 10 times now. That's like a 3x increase in the number of names. Is that statistically significant? Well, you have to be able to like make some sort of reasonable argument about that. So even if you can program, you still need to have the stats to be able to sort of ferret out these patterns and really kind of tease out subtle signals. So I think you will probably need to incorporate both. So an interesting question is, what are some of the difficulties turning information about data into actionable policies that impact a bottom line? So I think that's a really interesting question, and that's a really great question. So in fact, actually, I got asked by the Harvard Business Review to write a piece that's more or less along those lines. So I guess if you really wanted to read that, you should follow up on Twitter. I just wrote the piece, and it's sort of going through the review process and will probably be out in a week or two. But follow us on Twitter, and you can read more about that. The bottom line is really that I think it's really important to understand what kind of problems you're looking at and to find problems where there's a ability to have a high impact and not just sort of problems that are scientifically interesting. I think that's one of the challenges that people coming directly from academia often have, is that they want to solve problems that are interesting because that's what we're trained to do as academics, right? We want to solve problems that are fun to solve. But somehow that's not what industry wants. And oftentimes, the thing that the problems that are the most high impact, that will sort of deliver the most value, are not the ones that are the most sexy or glamorous, because not everyone needs a recommendation system, right? But they're fun to build. They're very technically interesting. But sometimes just doing something really dumb will get you there really quickly without the need to sort of do a lot of fancy data science. So yeah, so somebody said, if we apply for the online session, would it be something like today? So yeah, I guess like I would say this is probably something like what the data incubator is, a miniature version thereof. But except that all those difficulties you had in setting up your environment, all those kind of go away. So it actually just happens naturally because we will provision you a machine that has all that stuff sorted out. Oh, Fernando suggested removing punctuation from tweets might be a good idea. So yeah, you should definitely do that. I don't know if you want to remove non-ASCII characters necessarily, right? Because, for example, French has lots of words that have non-ASCII characters, or if not French, then Russian or Chinese or some language, and those are still worth doing some analysis on. But I agree with you that sort of punctuation is a useful thing to remove, and you should submit a pull request to do that, Fernando. All right, so it sounds like people are sort of slowly trickling out. And oh, sorry, there's a question about how to install online, the online LDB function. So all the installations are in the requirements.txt. So you can just sort of pip install that, and you should be able to just run. All right. This seems like an interesting question, but I don't think I quite understand what you're asking. Is there some format or experience about how to convert a problem into a data science problem? I think that's actually one of the really interesting things you have to understand, right? Is how can you, and that's one of the big challenges of data science, is how can you take a vague word problem and convert that into something that can be answered using a little bit of programming and a little bit of stats. And being able to do that is a very valuable skill. That's one of the things that we try to instill in our fellows, but it ultimately comes down to sort of being able to be creative and clever. Yes, so somebody asked us, the data incubator assist with networking and job search after the program? Absolutely. That's kind of what we do. So yeah, and then somebody asked, what can we do to help, or what differentiates the data incubator from other programs? I think sort of two things. One is that, well, it's free, right? So a lot of programs charge, and the way we work is it's completely free for the fellows, and then hiring companies are the ones who pay us if you sort of successfully are hired. And I think that correctly aligns everyone's incentives, because it means that we will only take people that we think are really strong and will have a good chance of being a data scientist. And then, and it also means that when we talk to the companies, that they take us really seriously because they understand that that's what we're doing. And then somebody asked about networking. Yeah, so we have lots of networking opportunities. In fact, we just finished a networking event in New York with some of our New York companies and New York fellows, and we're going to be doing tomorrow a event with our DC fellows and the DC fellows and DC companies. So we definitely do a lot with that. And then finally, oh, okay, it looks like I'm going to do a big call out here to Jack, our operations person, who's answering some of these questions for me. Oh, somebody mentioned emoticon LDA. That's pretty cool. Yeah, so this is all done in Python 2. So somebody said they're using Python 3. And in fact, if somebody wants to go and submit a pull request to the README to document that we're using Python 2, that would be really helpful. All right, cool. So it looks like we're kind of running out of questions. And I'm just going to get off now. But thank you so much for joining. I think I've gone completely over time. But this was fun. There was a lot of, it sounds like people were pretty interested and found this interesting. So maybe we'll do another one in a quarter or so. Bye.